Our last type of transformation is a dilation. So a dilation stretches or shrinks the function in reference to the pivot point. Now, in our quadratic function, a pivot point would be the vertex. Later on, when we get to some with asymptotes, the asymptotes are going to be where our pivot points are. But for now, we're going to look at two different cases. So I want you to get out your graphing calculator. Notice the very first thing we're going to graph is the quadratic parent function. All right, and then your second graph, you're going to multiply 1/2 times your quadratic parent function, and your third graph you're going to multiply by 2. So I have these plugged into Desmos. And the red graph is my parent function. The blue graph is where I have 1/2. And then the green graph is where I have a 2. So notice that blue graph looks a little wider, but the terminology we're going to use here is that it's a vertical compression. So think about if you were to go down and touch the ground, you're shrinking vertically, you're actually going to appear a little bit wider. Whereas if you have the green graph, think about stretching your arms up as high as you can, your body's getting taller and skinnier. So that's a vertical stretch, is the green graph. So we noticed this was a vertical compression or shrink. And then we had our vertical stretch. So when we had a fraction in front, we're compressing, we're shrinking that graph vertically. When we have a whole number greater than 1, we have a vertical stretch. All right, let's look at case 2. So again, we're starting with our quadratic parent function. We're going to graph that. And then notice the difference here. We've got parentheses where we're squaring outside of our parentheses. So we're going to graph that. And we'll notice it's kind of similar to the first set of graphs, but that blue one, look, it's quite a bit wider. We're actually going to call these our horizontal stretches and shrinks. So let's think about this, the blue graph. Imagine you're stretching your arms out to your sides. So you're stretching out horizontally. That's your horizontal stretch when you have a fraction in front of your x term. Versus that green graph, imagine pulling your arms inward. That would be your horizontal compression. So we're going to write that in. This was a horizontal stretch versus this horizontal compression. And notice we're going the opposite of what you would expect. So we see a fraction. You'd think it would shrink the graph, but it's actually stretching the graph. And then when you see a number greater than 1, you would think it's stretching, but it's actually compressing or shrinking. So it goes with the theme inside inverse. Remember, if we did x minus a number, we were actually moving to the right. So the inverse, the opposite of what you would expect. The same thing goes with dilations. All right, so our order of transformations, we've talked about this already a little bit, but just a reminder because it is very important. You will always, always, always do your horizontal translation first. So translation, that's your lefts and your rights. The letter we used was H for that. Next, we can do our reflections and dilations. So anything being multiplied to our x's and y's, the negatives, which reflect over the x and y axis, all of that can happen at the same time. And then our very last thing will always be our vertical translations. So that's our up and down. So you always go left and right first, which is your H term. And then you go up and down last, which is your K term. Okay, so we've got horizontal and vertical translations. A horizontal translation affects the x-coordinates. That's your left and right. Multiplication by positive constant dilates the function. So it's going to stretch or shrink it. And then on the other side, a vertical translation affects the y-coordinates. Multiplication by positive constant is going to dilate the function. Okay, so let's kind of sum this up in terms of f of x. So if we have y equals f of a times x, so this is multiplying inside the function. We're actually multiplying our x by 1 over a. So remember inverse, so we're going to multiply actually by the reciprocal. And now this is with an a value that's greater than 0. Whereas over here, if we have something being multiplied outside of our function, that multiplies our y by whatever that number is, by a. So let's go through a few examples. If we have f of 2 times x inside the function, so in the parentheses, this is going to multiply my x by 1 over 2, so 1/2. And that's a horizontal compression. All right, and if we multiply by 1/2 inside the function, we're actually going to multiply our x's by 2 over 1 or just 2, and that's our horizontal stretch. If we have 2 outside of the function, we're multiplying our y's by 2, vertical stretch, whereas if we have 1/2 outside of the function, we multiply our y's by 1/2.